Okay, jumping in side of this our subnetwork. I'm going to start by attribute promote our building ID to point, and also I'm going to do our scale to point, but by maximum. Okay. And then I'm going to add a wrangle here. And this is going to be what evaluates our building, or works out our building tags. We're not going to put anything in here yet. I'm going to do this in the next video because it's quite a, not a super long, but a decent chunk of code that I'll dedicate a whole video to. Let's have some more space. Let's add a blast in here. So now we can blast away our text. No longer need that. And another wrangle. And it's going to be our part type. Cool. And we are going to do this one. So is at part type, and we'll initialize this just to a blank string. So this is going to basically be our roofs, our walls, and our floors. And this is easy enough to do. We're just going to do it based on normal direction. So we go if and in dot y. Let's also make sure before we do this that we put in a normal here based on, and make it a primitive normal. I'll do by face area. It shouldn't matter too much though. Okay. So if our normal and our y is greater than 0.99, and rather than just doing equals to 1, this will give us a little bit of sort of tolerance for like floating point error and that sort of thing. Then we go at part type equals roof, and we'll color these so we can see them easily. And we'll just make that, oops, make that red. And we'll go else if, so if our normal is facing basically directly up, it's our roof. If our go at n dot y, if that is less than negative 0.99 or facing down, our part type is going to be equal to our floor. And we'll make that green. Then we just go else. Now we know if it's not a roof or a floor, it has to be a wall. And we'll make that green. So blue. So floors, walls, roofs. And the last piece of setup we need to do for this is we want to detect our roof edges. So say we've got this piece of roof here, we want to detect these edges along here. Just so, because later on we're going to generate barriers, and we need to know where to generate those barriers. Okay, so to do that, we're going to need another wrangle. Get roof edges. Okay, and this one wants to run over points. Let's go back, make sure this one is running over primitives. Okay, so what we need to do in here is do an integer, and then if we do square brackets, this makes this an array. So nay, short for neighbors. And we're going to look at each point and get its neighboring points. So we say we're looking at this point, we'll get this point, and this point. And we can just use this neighbors expression. First input, and look at the current point, or ptnum. Then we go I at roof edge equals 1. So 1 will be, it is an edge. And now we can just go for each and int point. So that'll be inside of our loop, the point we're looking at. And then we can search through this array of neighbors. So for each of the point's neighbors, we'll just store the position of the current neighbor that we're looking at, which is P, and we can just look at this point, because this will pull the this neighbor's returns basically an array of point IDs, and this value will be equal to the point ID it's pulled from this array. So we go if at p.y, and we'll go plus 0.01 just for a little bit of tolerance. It's greater than the position.y. That means it's not a roof edge because there is a point that's a neighboring point higher than it. Okay. Set that to 0, and then we can just break because we've already found one that's higher. We don't need to keep searching the array anymore. Cool. So basically, this will give us points that don't have any points higher to it in its neighbors, which won't give us these bits, but we will basically convert this to an edge group later, and then back to points, and we'll get repick up those points.